Hello everyone, welcome to today's class. Today we'll start with a very important topic known as differentiation. Okay. See, the calculus effectively is divided in two sections. One is differentiation, another majorly is integration. Okay. So let's start with the basic today only. Okay. Once again, differentiation. Basics. So let's start with some standard rules. Based on that, we'll govern some other rules. Okay. So first of all, start with d by dx. Okay. D by dx means differentiation with respect to x. Now this with respect to x means the whatever function I'll write here. Okay. So I'll write something in the bracket. That will be a function of x, means it will be in terms of x. Okay. So I can do d by dy also, d by dt also, depends on the question or depends on the requirement. Okay. Now basic some rules. D by dx of x raised to power n. Okay. So the rule is n x raised to power n minus 1. Power comes down, power becomes 1 less. Then d by dx of, we'll start with trigo now, sine x. The differentiation of sine x is cos x. Similarly, d by dx of cos x is minus sine x. Okay. D by dx of tan x is sec square x. D by dx of cot x is minus cosec square x. Then d by dx of sec x is sec x tan x in multiplication. D by dx of cosec x is minus cosec x cot x. Okay. Then d by dx of e raised to power x is e raised to power x. Okay. Then d by dx of a raised to power x is a raised to power x into log a. D by dx of a e then log x is 1 by x. Okay. So overall these are some standards. Okay. There will be some more. If required, I'll add it. Okay. Yeah, and one more thing, d by dx of any constant, okay, is 0. K is constant. If a constant is only differentiated, means it doesn't have any x, the differentiation becomes 0. Okay. And rest other properties are there, but I'll not explain that in terms of properties. We'll just understand with the help of example. Okay. Let's start with basic. Okay. Differentiate with respect to x. Okay. So suppose you are given first part. Okay. x raised to power 5. Okay, so the differentiation, let's consider this as a function. Y is this, then we have to calculate dy by dx. Differentiate means differentiation of y with respect to x, means dy dx of x raised to power 5. Okay, so that will be power will come down, so 5, and power will become 1 less. 5 minus 1, that's 4 directly. Okay, next level, let's take y as 3x square. Okay, so in that scenario, dy by dx, differentiation of it, means dy by dx of 3x square. Now point is, whenever you have a constant in multiplication, you leave it, you don't do anything with it, means basically we take it outside the differentiation. Dy by dx of x square means only the variable part or the x part will be differentiated, rest constant will be kept as it is. So this will become, differentiation of this becomes 3, 2 will come down and power becomes 1 less, so 3 into 2x, 6x. Okay, so whenever a constant is multiplied with some function, just leave the constant and differentiate directly. Although we'll not be writing this step from now onwards, but understand what is happening. If the constant is multiplied, leave it. If only constant is there, then only the differentiation becomes 0. Okay. Let's take next example. X cube plus x square plus x plus pi. Okay, this is your function y. Okay, so dy by dx means differentiation of this x, dy by dx of x cube plus x square plus x plus pi. Now what do? We can split this differentiation among each expression regarding along plus and minus. Basically means this differentiation can be splitted about plus and minus, simple enough. Means we have to differentiate each term individually. X cube, the differentiation of x cube is 3x square, power 1 less, power down, and power becomes 1 less. Differentiation of x square is 2x. Differentiation of x is d by dx of x, power is 1, 1 comes down, and differentiation, x raised to power becomes 1 less. 1 less means 0. So anything raised to power 0 is 1. So basically 1. Plus pi is constant. The differentiation of constant is 0. So answer is 3x square plus 2x plus 1. Okay. So now I have discussed two concepts. First is, if a constant is being multiplied with variable, leave the constant and just differentiate the variable part. And differentiation can be splitted about plus and minus. Okay. Although it is written in terms of property, I don't want to complicate things. I want to keep things simple enough. Okay. All right. Next we'll talk about is product rule. Okay. Known as UV. So every time in this chapter I say UV, you have to understand I'm talking about product rule. Now what does this rule do? UV dash is equal to U dash V plus V dash U. I'll explain what's dash. It's another notation. Basically, if I want to write dy by dx, I can simply write y dash. That also means differentiation. I can write y1 also, like this, y subscript 1. But this is rarely used. Mostly it's very much clearly written dy by dx, or sometimes they use this dash to represent differentiation. Okay. So dash means differentiation, means two functions are there. U means u was some function of x, v was some function of x. How do we differentiate that? We cannot directly say it's u dash v dash, means differentiation cannot be splitted directly with respect to your multiplication. So what do? We differentiate one variable at a time, keep other as it is, then differentiate the other part and keep the first one as it is. Okay. I'll illustrate this with the help of an example so you'll understand it clearly. Like if I give you a question, x sine x, okay, differentiate x sine x. So I'll write dash. Okay. So what does that mean? It means you differentiate first of all x, keep sine x as it is, plus then you differentiate sine x. Okay. Differentiate sine x. So sine x dash means differentiation and keeping x as it is. So we'll differentiate one thing at a time. X dash sine x plus sine x dash x, u dash v plus v dash u. Okay. So differentiation of x is 1, sine x as it is. Differentiation of sine x is cos x, x as it is. So let's rearrange. It is sine x plus x cos x. Okay. That's a very simple illustration of UV. Okay. Let's try to complicate it. X cube sine x by cos x, differentiation. Now you might think this is complicated because multiplication is there, also division is there. I haven't given you the rule for division right now. So try to think in terms of multiplication. Sine by cos can be rewritten as tan x, and now you have two things, u, v. Okay. So what do? We differentiate the first term, keep the other one as it is, tan x as it is, plus we differentiate the other term, tan x differentiation, keeping x cube as it is. X cube differentiation 3x square, tan x as it is, tan x differentiation sec square x, x cube as it is. Let's rearrange. 3x square tan x plus x cube sec square x. Okay. So far simple enough. Next, let's see one question. E raised to power x sine x plus x raised to power n cos x. We have to differentiate this. I'm not writing d by dx. Dash automatically implies differentiation. So first of all, we know we can split the differentiation among these two. So I can rewrite this as e raised to power x sine x. I have to differentiate this term plus I have to differentiate x raised to power n cos x. Now we have to apply uv here also, uv here also. Okay. So I'll take some more space. I'll start from here. So e raised to power x differentiation sine x as it is plus sine x differentiation e raised to power x as it is. Okay. Then x raised to power n differentiation cos x as it is. Okay. Plus cos x differentiation x raised to power n as it is. So it implies e raised to power x differentiation is e raised to power x only, sine x. Sine x differentiation is cos x, e raised to power x. X raised to power n differentiation is n x raised to power n minus 1 cos x. Cos x differentiation is minus sine x into x raised to power n. I can take e raised to power x common from these two. I can take x raised to power n minus 1 from this part common. So let's simplify. Something can be simplified, simplify it. E raised to power x sine x plus cos x plus this becomes x raised to power n minus 1. If I take common, I'll be left with n cos x minus x sine x. Okay, that's it. Okay, then differentiation of, you can do e raised to power x, x plus log x, differentiation of it. Now what we'll do is we'll consider this u. Okay, this e raised to power x is u, but this is slightly complicated, but still we'll completely call this as b. And the differentiation is e raised to power x differentiation, the other term as it is, x plus log x, plus differentiation of x plus log x, e raised to power x as it is. So differentiation of e raised to power x is e raised to power x, x plus log x, and differentiation of this term, what we'll do is we'll differentiate first x, whose differentiation is 1, and log x differentiation is 1 by x. From the complete expression I can see e raised to power x is common, so I'll take e raised to power x common, x plus log x plus 1 plus 1 by x. Okay, slightly long, but yes, this is the answer. This is just to make you understand how do we apply UV. I think this is more than enough. Okay, you can work out your own examples. Okay, plus we'll be doing UV in the later stages of differentiation also. It will come in between. Right now we are focusing on UV, but then UV will be an intermediate step. Okay, that's pretty okay. Let's take it one more level up. So as such it's not a rule, but I'll modify this slightly. I'll get some space. There's no such thing as UVW, but you can think how this could work. Okay, one second. It's not changing. Okay, UVW. Suppose instead of 2 functions, 3 functions are there, then what will you do? This rule is still the same. You differentiate one function, keep the other 2 as it is, then you differentiate the second function, keep the other 2 as it is, UW, then you differentiate the last function, W, keep UV as it is. Okay. All right. Now let's use that. The question is differentiate x cube e raised to power x sine x. Differentiate this. Something wrong. Now it's working. So the differentiation becomes differentiation of x cube e raised to power x as it is, sine x as it is. Then differentiation of e raised to power x, keep x cube and sine x as it is. Then differentiation of sine x, keep e raised to power x and x cube as it is. So differentiate one function at a time, keep the other two as it is. So x cube differentiation, power down, 1 power less 3x square, e raised to power x sin x. Differentiation of e raised to power x is e raised to power x cube sin x, and differentiation of sin x is cos x, e raised to power x cube. E raised to power x is again common, and x square is also common. So e raised to power x and x square common. What is left? Let's take e raised to power x only. If you feel this is slightly complicated, e raised to power x as it is 3x square sin x, x cube sin x, e raised to power x is common now, so x cube cos x. If you want, now you can take x cube common. Okay. So e raised to power x, e raised to power x, e raised to power, this was common, so I have taken that out. Okay. If you further want to take x square common, you can do e raised to power x square, now 3 sin x plus x sin x plus x cos x. Okay, that was UVW. Let's let me give you one more example. So the question is x raised to power n log base ax e raised to power x. Now for that I need to explain to you how log works. Okay, so some intro to log here. As such, if nothing is mentioned, usually log x means log base ex, okay, which is sometimes written as ln x in order to avoid the confusion. Okay, but this is standard. Log x means log base e or ln x. This is applicable in maths. Okay, remember that. So the differentiation, when I told you, let's go back to the rules. The differentiation, when I was telling you that log x differentiation, basically if I have not written base e, it still means this is ln x or log base ex. So that's good. Now I just left some space. So what will be the differentiation of log base ax? Okay, that will be equal to 1 by x log a. You can take this as a rule. This will help you. If suppose base is given something specific, then that log will come in denominator. Okay, now let's use this idea here in this question. Remember this, that ln x or log x, this is pretty much standard in maths. Okay, in physics and chemistry, usually, see, the problem is like in physics and chemistry, log base 10x is considered as log x. So either the question should be very clear while writing, okay, or they should mention what's your base. Okay, let's differentiate. Okay, we have to differentiate this now. So differentiation of x raised to power n log base ax as it is, e raised to power x as it is, plus x raised to, then differentiation of second function now. Second function is log a base ax differentiation, x raised to power n as it is, e raised to power x as it is, then differentiation of e raised to power x raised to power n as it is, log base ax as it is. The differentiation is n x raised to power n minus 1 log base x e raised to power x, everything is in multiplication. Differentiation of log base ax is 1 by x log a. Now we know x raised to power n e raised to power x, plus e raised to power x differentiation is e raised to power x raised to power n log base ax. Again, you can see e raised to power x is common in every single expression, and x raised to power n minus 1 again you can take common, but I'll keep it simple. E raised to power x common, rest you can do accordingly, plus, interestingly this can be solved, x raised to power n upon x raised to power n upon x, this becomes again x raised to power n minus 1, e raised to power x is gone, so upon log a, remember that's log a only, and remember last term is x raised to power n log base ax. Further taking one more step, taking now x raised to power n minus 1 and from this I have to take x raised to power n minus 1 common, so that gives n log base ax plus 1 by log a plus x log base ax. Okay. All right. So we are done with uv. Now we'll do quotient rule. Known as u by v. Again I'll give this in terms of dash. So u by v dash is v square u dash v minus v dash u. Okay, if you look at the numerator expression, it's same, instead of plus there is minus first of all, and denominator becomes v square. Okay, all right, so let's see. Let's see the example. E raised to power x upon 1 plus sine x. We have to differentiate this. So denominator square, so 1 plus sine x whole square. Don't open unless you think it can be simplified or it will help you to solve something, which usually doesn't. Okay, so keep it in the factorized form. Now let's write down numerator. Differentiation of numerator first 1 plus sine x as it is, minus, then do the reverse, 1 plus sine x differentiation e raised to power x as it is. So this becomes e raised to power x 1 plus sine x minus, this becomes 1 plus sine x differentiation is cos x, differentiation of 1 is 0, differentiation of sine x is cos x. Okay, and this becomes e raised to power x 1 plus sine x whole square. E raised to power x you can take common again, so it will become 1 plus sine x minus cos x upon 1 plus sine x whole square. That's it. That's the maximum you can do. Okay. All right. This gives you an idea how to go about u by v. Let's take few more examples. Okay, remember this is just basics of uv and u by v. They'll not give you a question based on this as such. Now differentiation of sin x plus cos x upon sin x minus cos x. Okay, you have to differentiate this. So denominator square instead of sin x minus cos x whole square. Okay, this is our u, this is our v now. Earlier it was u, this was v. So now differentiation of numerator, sin x plus cos x dash sin x minus cos x as it is minus, this time do the reverse, sin x minus cos x differentiation sin x plus cos x as it is. Differentiation of sin x plus cos x is cos x minus sin x. This is sin x minus cos x. Differentiation of this sine is cos and cos is minus sine, so minus of minus sine, so it will become plus sine. This is sin x plus cos x. Okay, space. We need much more space here. Yeah, some space now. Cos x. Denominator is sin x minus cos x whole square. Now you can see these two terms are technically same. It's just that there is a difference in sign. So what you can do is take negative common and it will be sin x minus cos x whole square, and this one is sin x plus cos x. Sin x plus cos x written twice, so sin x plus cos x whole square, and the denominator is sin x minus cos x whole square. Okay, let's see. Let's open the bracket, because once you open the bracket slightly, you know this will generate sin square plus cos square, which is 1. So at least something is getting simplified. And then in the numerator, what you can do is both terms are negative, so you take negative common. This becomes addition. Now this is like a minus b whole square and a plus b whole square. Open it. This will give you minus 2ab. This will give you plus 2ab. So they will cancel each other. So effectively what you will get is 2 sin square x plus 2 cos square x. Okay, if you want you can open it on your own easily. Okay, a square plus b square minus 2 sin x cos x, like a square plus b square again plus 2 sin x cos x, so that will cancel. Okay, denominator again becomes sin square x plus cos square x minus 2 sin x cos x. Okay, now the numerator becomes 2. If we take 2 also common, it will become sin square plus cos square, which is 1, because sin square theta plus cos square theta is 1 na? And denominator again, this one also becomes 1, sin square plus cos square. Okay, sin square plus cos square after taking 2 common. So 2 upon 1 minus, what is 2 sin x cos x from trigo? That's sin 2x. So basically the answer is minus 2 upon 1 minus sin 2x. Okay, this is the simplified answer for this question. Okay, okay, all right. It's not like they can give you the question only on trigo. They can give you a question on polynomials also. 2x plus 3 upon x minus, sorry, x square minus 5, differentiation of this. Let's do last one. Okay, so x square minus 5, denominator whole square, differentiate numerator first, 2x plus 3 dash. This time I'll do direct. Okay, otherwise it will take time. U p. So first we do u dash. So differentiation of 2x plus 3 will be constant differentiation, only this is constant, so leave it. Differentiation becomes 0. Differentiation of 2 will not do, differentiation of x will do. Differentiation of x is 1, so only 2 will be left, into x square minus 5 as it is, minus, now differentiation of x square minus 5. So again 5 is constant, differentiation becomes 0. Differentiation of x square is 2x. Okay, so 2x into 2x plus 3. Multiply it, you'll get 2x square minus 10 minus 4x square minus 6x upon x square minus 5 whole square. There is no point in opening the denominator whole square. Okay, so this becomes minus 2x square minus 6x minus 10 upon x square minus 5. If we take negative common, everything becomes plus. Okay, you can take further 2 also common, x square minus 5 whole square. Pretty much this is the answer. Okay, all right, now we have done some basic of u by b also. Okay. All right, I think that's more than enough for the introduction. Okay. One property regarding log. Okay, I'll add here one interesting property, and some interesting questions can also arise due to that property. Why it's not working? One important property is e raised to power log x. Right. Colors, 1 second. So e raised to power log x is x only. Okay. So how this property will be used, this is a very important one as such. Let's see in a question. Suppose I give you I think I'll give you the properties of log here only. Okay, because then multiple questions can arise using that. So e raised to power log is this, then there is one more property that log x raised to power n becomes n log x. Okay. Then log a plus log b is log ab. Log a minus log b is log a by b. Okay. Addition, subtraction, power I've given you, cancellation also I've given you. Okay, that's it. Majorly these are some standard properties. Okay. Regarding log. Let's see the question that I was talking about. It's not difficult, it's just that it's tricky. Okay, if you know the trick, you can easily do this. The question is differentiation of, let's say, e raised to power a log x. This is the question. Okay, it's clearly looking I'll start with a number first. Okay, e raised to power 2 log x. It's clearly looking very much complicated right now, but see, the property is log x raised to power n is n log x. That means I can take this n in power of x also. Same thing I'll do here also. I'll take this 2 in the power of x. Okay, so this can be rewritten as e raised to power log x square differentiation. Now e raised to power log cancel each other, so it becomes only x square differentiation, which is 2x. And look at the differentiation now. It's very simple compared to what was the question. It was looking very ugly. Okay, they can give you a question like this also. E raised to power log, this is x log a, like this. Okay, differentiation of this. So what you can do is, the idea is that whatever number is written in, whatever number or variable can be taken in the power of log. So this becomes e raised to power log a raised to power x differentiation. E and log cancel each other, so it becomes a raised to power x differentiation. What is a raised to power x differentiation? A raised to power x log a. It's as simple as that. Okay, all right. That's it. I'll end the session here. Okay, we'll continue with the differentiation in the upcoming class. So see you in the next class. Good day everyone. Bye.